All right, good morning, class. So, after grading through W2.11 carefully, uh, there's some mistakes are being made, and this is a nice little kind of catch up for it. So, the topic is not particularly hard, we just need to get sharp. So, check this out while we go through some of the questions from W2.11. You want to watch this video before you go through W2.11B. All right, let's try to go quickly. Now, the questioning up top, truthfully, I'm not a great fan of it. We're going to call north upward on the page, and I think I'm going to rewrite this one in the future to say two winds, 140 knots, let's say here, eastward, and 125 knots, let's have an unknown direction. Okay, fine. What's the maximum wind the object can experience? At what relative angle? So hopefully by now we practice in class a bit. You know that the maximum resultant happens when the two vectors are oriented at 0 degrees to each other, basically in the same direction. Similarly, but the reverse case down here, the minimum wind, the resultant minimum is going to be at 180 degrees. That's the theta, and that's when these are in the opposite direction. Fine. So then the question says, what is the max wind that the object can experience? Well, truthfully, this is I'm going to leave you much space. You'll see on 211B there is. This is really a givens with units question before you go sketching everything in. Let's call eastward positive. Put that over here for this problem. And so the velocity of wind 1 is positive 40 knots. And if we want them in the same direction here, you want the max, they have to be pointing the same way. So the velocity of wind 2 is going to be positive 25 knots. And then finally, the max wind, velocity resultant max, that's what we're trying to find here. We'll notice these two are in the same direction. Please get in the habit of writing this out with the givens too. So the velocity of resultant max is just going to be this, the velocity of 1 plus the velocity of 2. Quick version here, of course, is the 40 plus 25. The math part is easy here, but let's make sure we get sharp with that. The minimum is the same sort of thing over here. You know, the velocity, the resultant min, be our question mark. Now, notice we have these pointing oppositely. So our givens actually, wind 1 will be positive 40 knots, but wind 2 is going to be pointing the other way, negative 25 knots. All right, so be formal with it. Be formal with your setup. Don't skip over those givens, even with your drawing questions. Now, questions 2 and 4, that hopefully you're better at it, but a lot of people just kind of had an arrow on there. They weren't sure what to do with it. Now, listen, I've given you more directions here. I'm telling you that 40 is eastward. Eastward is to the right. I understand first time around directions were a little bit loose. So this should be better this time around. Don't feel bad if the first time was troublesome. Just get it right this time. So 1 centimeter is 10 knots. Well, this is a quick one over here. I mean, I'll show you it formally once, as we've done in class. So the 40 knot wind, our givens here, we have velocity of wind 1, velocity of wind 2. So wind 1 was positive 40 knots, and wind 2 was positive 25 knots for this scenario, for the max scenario. You can easily convert these, get rid of the knots, turn it into centimeters. So 1 centimeter is 10 knots. Of course, 40 divided 10 is 4.0 centimeters. This one will also give you then 2.5 centimeters. So if we're sketching these eastward, you need to come over here, put your ruler. You don't necessarily have to have a protractor. Heck, you can use a tape measure. It doesn't really matter. We need to go, I'll go from the middle of the dot. We're going to go 4 centimeters. Since north is up, east will lead to the right. So I'm going to start right here. 1, 2, 3, 4. Stop right there. There's my wind 1, which is 40 knots. And then we have wind 2, which is 25 knots. Now you can draw it wherever the heck. Maybe we'll come draw it down over here. But of course, head to tail. Head to tail is our obligation. So it makes more sense to come over here and just draw this one straight on the head of the prior. Head to tail, another 2.5 centimeters right there. That's velocity of wind 2, 25 knots. Now, how do you do your resultant? Yes, this is an easy one. We know that. But practice the format now. Circle the start. That's the exposed tail. X the finish. That's the exposed head. And then draw the result. And of course, here the resultant should be 6.5 centimeters. My ruler is blocked out here. Why? Who knows? But we can always just start at 10 instead and go over to 16.5, whatever it is. So we'll get in here, move over, draw that, arrowhead on it, done. There's my resultant velocity here, which came out to 65 knots. All right, that's the process. You can repeat the same thing down here. And of course, your velocity 1 down here is going to be that 4 centimeters, and this one is going to be to the right. But velocity 2, because we're doing this opposite direction, is going to be 2.5 centimeters, but this time to the left. So when you draw this, draw your 4 centimeters right. There it is. That could be V1, which is 40 knots. Then you have to draw your 2.5 centimeters left. Okay? Don't just put it anywhere. I mean, heck, you could draw it over here. That's fine, but you're going to have to end up moving it. You got to move it so it's head to tail. So we need 2.5 centimeters the other way. Now you can leave your ruler and just line up the 2.5 mark and go back. If you don't like that, flip your ruler upside down. 0 is right there. And so you're going to go, I'll try to go a little below it just so you can see it. And go here to 2.5 centimeters is right there. Arrowhead back. This one is velocity 2, which is 25 knots. Now the part a lot of people left off is this. Like, what do we do here? Well, exposed tail is circle the start. Follow the arrows. And then this one connects to this tail and brings you back. Exposed head is right here. So your resultant is really just, let's go back to centimeters. From here to there. That is the resultant. There's your velocity. Sorry, mine's a little off angle, which of course is 15 knots to the right. Okay? And you had figured that out in question 3. What's the minimum wind? That's at 15 knots. Okay? That's like getting sharp on these. You need to be sharp like this. Not too much else to talk about on this homework other than to say over here, the plane, the jet stream problem. So 211B, you're going to have a question like this. It's all it is. It's the same as this, just spread out over a whole page. There's no rush. There's no squeeze. Then you're going to have a question kind of like this. That's it. The back we didn't repeat. So here we have all this information about this. Commercial airliners, etc. Set up your givens. I know I didn't give you much room. Again, take credit for that. On 211B, it'll look much better. Commercial airliners fly at approximately 225 meters per second in still air. Jet stream, which is a flow of the air itself. It's a wind. It moves from west to east, so you can say it's eastward at 45 meters per second. Okay, this, by the way, varies, but you pick that for this problem. So if an airplane flies from New York to LA while in the jet stream, what is the plane's resultant velocity? You should be over here setting up your givens with units. Let's not change that. That's a good habit we've developed. Keep that going. Set up your givens with units. So over here, you can call this like the engine or the plane velocity. The velocity of like the engine is 225 meters per second. Fine. The jet stream, velocity of the jet stream is 45 meters per second. Now, in this problem, they're telling us if the plane flies from New York to LA. So here it's flying. This is called westward. Now, it doesn't really matter which one you call positive, but since this problem is flying westward, I'm going to call west positive. The plane is following that west. The plane flies from New York to LA, so this is a positive. The jet stream always moves eastward. That's got to be a negative. We'll put a negative over here by my 45. Should have left a little more space. Then they say, what's the resultant velocity? Velocity resultant is the question mark. So you can turn this into a drawing at this point. That's fine. In fact, here, you can make this either a drawing, or you can make this just with simple vector addition, we call it, just a problem. Either way is okay. So I'll break this into, A, B. But this piece should be here. This should always be here. All right, if you're doing the algebraic method, the resultant is always the individuals added. So the engine plus the jet stream. And of course, when you plug it in, you'll see positive 225, negative 45. It'll shrink down to 180, as we had here in the key. The 180 comes out positive, of course, which is why it's westward. Now, if you had chosen east positive, then your answer would have come out negative, which would still mean west. So it doesn't matter. If you're going to do the vector version, this is a sketch here. You didn't have to draw these to scale. So eastward you could make, like here it is. Here's the engine, which represents 225. Now the mistake people made is, where did they put that next arrow? The 45 is going westward. Eastward. I think I just messed that up for you. This one is going westward. That's the way we started. If that's west, then north would be down on the piece of paper. Not a big deal. You can choose that. So then eastward, the 45 is going to go the other way. Tack it on head to tail, just like that. Now 45 is less than 225. Who cares how much less? It's just less. There it is. There's your velocity of the jet stream. That one's 45 the other way. Please, with your sketch, circle the start, X the finish. There is your resultant. From circle to X. There is your resultant. That's the resultant. But hopefully there you see it's 225 minus 45. Okay? Of course, if the plane instead goes from LA to New York, that's the reverse flight. Your givens with units over here. Now your engine velocity is going from LA to New York is east. We called west positive, so east will be negative 225. The jet stream is still negative 45, and they want to know the result. You have the same two methods available to you. Of course, to set up the algebraic, just plug them in. You'll get now negative 270, which based on our west is positive, is then east. And then if you do it this way, notice the jet stream will not change. The jet stream is still this. But now your plane engine velocity is directed to the west. So, sorry, to the east. So I keep messing that up. There we go. We're going the same way now. Okay? There's your velocity of the engine. Should have made north up. It's more convenient for the way we think. Good. And then circle the start, X the finish. There is your resultant velocity. Okay? Down at the bottom, determine the travel time. A lot of you started doing proportions and some other business. Cut that out. Givens with units. We've been doing this. Don't give it up. It works. Do it all year. Even if you end up doing a drawing, start out with givens with units. It's the best way to organize your problem. Okay. Determine the travel time, blah, blah, blah. Okay. So we know here each direction. So we're actually doing this problem twice. But let's just pick one direction to talk about. The givens with units, we know, let's do the flying westward direction. We found out that the resultant velocity, let's call westward positive here. The resultant velocity was, we had it down here in the key, 180, call that plus, meters per second. All right? For the other version, that one was going to be 270 meters per second. If we stick to the west as positive, that would be negative. You're allowed to switch from problem to problem, by the way. Whatever's convenient is just fine. As long as you remind yourself and put the notation of whatever is positive there. Okay, they told you the distance. 3.944 mega in your reference table is a capital M meters. If you look up mega on PRT1, it says times 10 to the 6th. So this is just 3.944 times 10 to the 6th meters. It's fine. You don't need to then turn it into standard notation. That'll do. The question is travel time, T equals question mark, and seconds. If you notice in the key, we're in units of seconds. So how do we do this? We have an equation. V bar is D over T. Please don't avoid the gives with units. That's the way to do these. If they ask you to draw, yeah, at this point maybe you go make a drawing. But otherwise, keep going. The full guess format. Givens with units, equation, substitute, solve. This is the equation. If you want to solve for time, please be careful here. You can swap diagonals on a cross multiply. So T equals D over V bar. And then substitute solve. T equals 3.944 times 10 to the 6 meters over 180. You'll get an answer. It comes out in the thousands of seconds. And that's why I ended up putting the kilo down here. The kilo down here. All right? Just to make sure you're paying attention. Okay, that's it. I mean, brief mention of the back is when you draw these, it's the same deal as we just did on the front. It's the same deal where if you're drawing two vectors that are combining to make a bigger or a smaller vector, make sure you are drawing one, then the other, circle, X, resultant. Okay? Same thing. One, then the other, make them head to tail. If they point together, if they point opposite, you still make them head to tail. Circle, X, there's the resultant. You know, that part is very important. This is 1, 2, 1, 2. Very important to follow that process because when the diagrams get a little more complicated, you want to be automatic in the habit of draw the two vectors, or maybe even three, orient them head to tail, find that exposed tail, circle, find that exposed head, X, and then make your resultant from the circle to the X. And you'll be good to go on these. All right.